This is Indi Kalupahana. Today we are going to discuss the last lesson of physics, that is matter and radiation. If you can remember, in unit number 4, under the methods of heat transfer, we mentioned that there are 3 methods of transferring heat from one point to another. Those are conduction, convection, and radiation. So in this session, we are going to discuss about the radiation, the third method of transferring heat, and that is the quickest mode of transferring heat from one point to another. So if you look at this diagram, you can see for conduction and convection, they need a material medium to transfer heat. So here, if you put a rod, solid rod, closer to this fire, through that rod, the heat is transferred to the hand, up to the hand. And if you keep your hand above the fire, you will feel the heat because the convection current will always go upward. But if you keep your hands by the side of the fire, you will also feel the heat because that is due to the thermal radiation emitted by this fire. So thermal radiation is the radiation emitted by hot objects. That's why we call them as thermal radiation. All the hot objects can emit their own radiation. Even the human body can emit thermal radiation. So that's why we call them as thermal radiation. So it's a radiation is a process by which electromagnetic energy is transmitted from one place to another without any intervening medium. So these thermal radiation are the same electromagnetic waves that we have already discussed in unit number 3 under electromagnetic spectrum. So all these UV rays, IR, visible, X-rays, gamma rays, all of those are known as thermal radiation as well as electromagnetic radiation. So all the properties belong to electromagnetic radiation, belongs to thermal radiation as well. So all the objects having temperature above absolute zero can emit thermal radiation. All the hot objects can emit all the radiation. They are in the electromagnetic spectrum, but not in equal amounts. Some radiation, the amount of some radiation are higher than those on the very high frequency side and very low frequency side. For example, a certain object, hot object, can emit radiation larger from UV, visible, and IR. If you take a certain object, now look at this fire. Normally the color of the fire is like orange, red color. So this fire is emitting all the radiation which is there in the region of gamma. It can emit gamma rays, UV rays, visible light, IR. So it can emit all these radiations. They are in the spectrum. But as we can see it in red color or orange color, we can consider it has emitted more waves in the visible region, also in red color and orange color. It has emitted more waves in the region red color and orange color. And if you are closer to that fire, you will feel the heat because it has emitted IR. It has emitted more waves from IR also. Normally, we feel IR as heat waves. Therefore, the two regions that the humans can feel is IR and visible. Visible, of course, we can see them. IR, we can feel them as heat waves. The next para say, when radiation falls on a surface of a body, some is reflected and some is absorbed. So if this is a certain object surface, then radiation is incident on it. Some radiation can be absorbed by the object and some can be reflected. If a body is in thermal equilibrium with its surrounding and at constant temperature, it must emit and absorb the same amount of radiation energy per unit time. The radiation emitted or absorbed under these circumstances is known as thermal radiation. So we can define the thermal radiation as the thermal radiation is the radiation emitted by a body due to its own temperature. Due to its own temperature, objects can emit electromagnetic waves. Those are known as thermal radiation. And with the increase in temperature, the amount of radiation emitted by the object is also increasing. Therefore, the hottest known object for us is the sun. Therefore, sun can emit a lot of thermal radiation, and the maximum intensity of radiation is emitted by sun. And this is also important. Radiation is the quickest mode of transferring energy. Now we have conduction and convection. Other than those two, radiation is the quickest mode of transferring energy. The maximum intensity of thermal radiation lies in the region of UV, visible and IR. Most of the objects will emit radiation from these regions. Although they can emit all those spectrum, most of the radiations are coming from these UV, visible and IR. All objects constantly emit and absorb thermal radiation depending on surrounding temperature and its own temperature. If the body increases its temperature, the maximum intensity of thermal radiation emitted by it shifts from infrared to visible range, making it visible to us as red hot. That is interesting because we can take one example. Just think that we have a metal ball and we are supplying heat continuously to this object. Because of that, the temperature of this object is gradually increasing. If you are closer to the object here, you can feel the heat. It's hot. Because at this given temperature, it has emitted more IR waves. This object will emit all the radiation, but it has emitted more IR waves. That's why you will feel the heat from this object. But if you increase the temperature of this object further, of this metal ball further, you will see that it is the color is changing to red. So it's getting red hot. We call it as getting red hot. Why we observe this as getting red hot? Because with the increase in temperature, now the temperature has further gone up. Because of that high temperature, the maximum intensity of thermal radiation emitted by it is shifting from infrared to visible range. Previously, it has emitted more IR waves. With the increase in temperature, now it has got shifted to visible range. After IR, the visible range is starting from red, then orange, like that. So after IR, this object has started emitting more red color waves. That's why we see it as it is in red color. If you can further increase the temperature of this thing, then what would happen? Then this red color will get changed to orange color because it will start emitting more from orange color. So it will emit more orange. So with the increase in temperature, it is shifting towards high frequency region. That's the idea of it. With the increase in temperature, the maximum intensity of radiation emitted by the object is shifting towards high frequency region. So then we can discuss the characteristics of thermal radiation. So the first characteristic, those are the same characteristics that we have already discussed in waves, for the electromagnetic waves. So all these are electromagnetic waves, they have the same properties. Thermal radiation are the radiation emitted by a body due to its own temperature. Then it says no need of material medium to transfer heat. And it can travel at a speed of light at the vacuum or air. So all the thermal radiation or electromagnetic radiation has got this temperature speed in vacuum or air. Only in vacuum or air those waves got this value. In different medium have different speeds. For example, if the electromagnetic radiation goes to water medium or glass medium, it's not this value, but it's a different, lower value. Absorb and emit effectively by black rough surfaces. That is also you should know, all the thermal radiation will be absorbed by black rough surfaces than the shiny surfaces. Shiny surfaces will reflect. Shiny surfaces will reflect thermal radiation than absorbing it. So reflect effectively by shiny surfaces. Then the factors affecting emission and absorption of radiation body. These are the factors. Surface area. With the increase in surface area, the object can absorb or emit more radiation. Then second one is temperature. With the increase in temperature, the emission of radiation by the object also increases. And nature of the surface. Nature of the surface means whether it's black rough surfaces or shiny surfaces, depending on the nature, rough or smooth. That nature will determine the amount of radiation absorbed by it. Then the next topic that we are going to discuss here is about black bodies. Black body is a perfect radiator. It's a perfect radiator. If it is a perfect radiator, then it should be able to absorb all the radiation incident on it. Now, if you take this object as a black body, then it should be able to absorb all the radiation incident on it without reflecting any of these. And on the other hand, that the same object should be able to emit all the radiation absorbed by it. Then we can call it as a perfect radiator. So black body is a perfect radiator. Black body can absorb all the radiation incident on it and emit all the radiation after absorption. The reason to call this as a black body, because the color comes due to the wavelength which is being reflected. For example, you can see this object as red. Because why? When the visible light is incident on it, then this object will absorb all the wavelengths except the red color. It will absorb all the other frequencies except the frequency of the red color. So this red color will be reflected, and that wave goes to our eye, so we will see this object as in red color. Black is not a color. If you see a certain object in black color, which means when a radiation is incident on it, none of the radiation has been reflected. All those radiation has been absorbed by this object. So as nothing is getting reflected, you don't see any color of this object. So you call it as it is in black. So black body should be a perfect radiator then, because if all the radiation energy can be absorbed by it, then it's a perfect radiator. Then there are some terms that we need to know before going for the further discussion. The first term you take emissive power. Emissive power given by the symbol E lambda, also known as radiation intensity. Radiation intensity. So radiation intensity is at a given temperature and for a particular wavelength is the radiation energy emitted per unit area, per unit time, per unit wavelength range. So radiation intensity is the radiation energy emitted per unit area, per unit time, per unit wavelength range. That means if you take a certain black body, or we'll say even a normal body object, it's having a certain T temperature and it's emitting wavelengths, thermal radiation. So it can emit all the wavelengths. Out of those all the wavelengths, we are selecting a particular wavelength. We'll take it as lambda. From this wavelength, it's emitting, let's say 100 joules of energy per 1 second per 1 square meter area of its surface. So for this particular wavelength, the radiation intensity is 100 joules. That is the idea of radiation intensity. The amount of radiation emitted per unit area, per unit time by a certain particular wavelength. So you get this equation to find the radiation intensity. E lambda equals P over A. P is the power. Energy per 1 second is the power. Energy per 1 second is the power. That is watt. And we need to also calculate it for 1 square meter area. So this is area. So what is the unit of E lambda? Unit of E lambda. Power is given by watt. Area is square meter. Therefore, unit of E lambda is watt per square meter. So it's here. So it's here, but this part, it has been there within brackets to mention the particular wavelength that you have considered. Particular wavelength that you have considered. Then the next term is surface absorptivity given by the symbol A, also known as absorptive power. If you look at the equation, then you can identify the meaning of this. It says A is radiation absorbed by a body at a given temperature, radiation incident on it at the same temperature. For example, if you take a certain object, the thermal radiation is incident on it. We say there are 100 joules of thermal energy, thermal radiation is incident on it. But as some are getting reflected, only 80 joules of it being absorbed. Therefore, the absorptive power of this object is, say, radiation absorbed by the object, that is 80 divided by radiation incident on it, 100. So you get 0.8. 0.8 is the absorptive power here. And you can see that is less than 1. For normal objects, you get the absorptive power always less than 1. But for black bodies, the absorptive power is 1. You don't get any object which is having the absorptive power more than 1. You don't have such objects. Black body got the maximum intensity of radiation. Therefore, it can emit the highest amount of radiation at a given temperature. All the other normal objects will emit radiation less than that. Therefore, for black bodies, A is equal to 1. For normal objects, A is less than 1. Black body has A is equal to 1 because if this is a black body, then it should be able to absorb all the radiation incident on it. If 100 joules of energy is incident on it, then that total amount will be absorbed by the black body. Therefore, A is equal to 1. Next term is surface emissivity given by the symbol E. Look at this expression for you to understand. E. Radiation emitted by a body at a given temperature divided by radiation emitted by black body having the same surface area and at the same temperature. So this is kind of a comparison between a normal object and a black body. We take this one as the normal object and this one as the black body. Imagine both of them got the same area, surface area and same temperature. So at the given temperature, this object will emit, the normal object will emit energy. Let's say this is 80 joules. 80 joules of energy is emitted by this normal object. But for the black body at the same temperature and for the same surface area, it will emit more than this. So let's say that is 100. So the surface emissivity of this normal object E is given by radiation emitted by the object at the given temperature, that is 80, divided by radiation emitted by black body, that is 100. That is also 0.8. And again it is less than 1. So normal objects, surface emissivity is less than 1. But for black bodies, it is equal to 1. You don't have other objects which is having E more than 1. Black body has the highest intensity of emitting radiation. All the other objects are less than that. This value of A and E should be between 0 to 1 for non-black bodies. For non-black bodies, the values are between 0 to 1. And this is also important, A is equal to E. Either it is a black body or non-black body, doesn't matter, always the value of A is equal to E. The absorptive power of black body is 1. All black objects are nearly black bodies. So all those black objects, we can consider them as nearly black bodies because a perfect black body is an hypothetical object.